Yeah, we can start. Good afternoon, students. Today we are going to study maxima and minima. As last class you have already went through this topic, maxima and minima. We will short recap all the points, important points, and then we will see how these points can be applied to any type of question. Either a question could be of a basic nature, or it could be of an average nature, or it could be of a higher nature. Like you have to basically understand the application of all those points. So right now, when we talk about maxima and minima, the few points we have to know from maxima and minima. Firstly, when we talk about the definition of maxima and minima, so we know that any function can have a maxima at a point A or can have a minima at a point A under some condition. Like x equal to A is a point of maxima of a function fx when we say that f of A is actually greater than f of A plus h, and f of A is actually greater than f of A minus h, and where h is a quantity which is positive, as well as h is a very small quantity. So I am not going into the detail of this theoretical part, but we have to understand कि in the neighboring region of A, the function is having the highest value as compared to right of A as well as left of A. Then we say that it is a point of maxima for fx. And when we say similarly, point everything goes similarly, that it is a point of minima x equal to A, when we say that f of A is actually less than f of A plus h, as well as f of A is less than f of A minus h. So this is actually the definition. Now this definition has been used in various questions. Like even in IIT JEE question, there was a question where this definition has been used. The question was like this: a function was given. Let me write the definition. Let me write the function for you. It is fx equal to mod of x for mod of x between 2 and 0, and it is 1 for x equal to 0. Then at x equal to 0, I am not giving you the option right now, though there was options given. You just have to tell that the function f at x equal to 0 has a maxima or minima or nothing, like something of like that kind. So basically when we talk about the definition of maxima and minima, so in that case we can find that at x equal to 0 whether it is a maxima or minima. If you go to the definition of which we have studied just now, fx equal to mod x is a function like this, but at x equal to 0 it has not been defined as fx equal to mod x. At x equal to 0 it has been defined as 1. So this point will not be included, and this is a discontinuous function. Mod x is between 0 to 2, that means ki it is between minus 2 to 2 except 0, which we know about mod. So it is between minus 2 to 2 except 0, and at x equal to 0 this value will jump to 1. Now when we see this function, normally by definition we say that this is a point of maxima, and that is true. Though this is a usual conceptual mistake that people think about derivatives and all those things, but firstly we think about definition, and this is a point of maxima. I hope this is clear to everyone. Now we go to how do we test maxima and minima by method of derivative. So when we talk about method of derivative for checking maxima and minima, in that case we have basically three methods. One is single derivative method, another is double derivative method, and third one is nth derivative method. Single derivative method, as we have previously studied as well, single derivative method simply says कि if a function is differentiable at a point and that is equal to 0, the derivative is 0 at that point. So let that point be a, f dash a equal to 0. So a could be a point of maxima or minima, or if the function is not defined, in that case also maxima or minima could be there. But right now we are talking about the test, first derivative test. So here we are just focusing on that derivative of the function is equal to 0 at that point. And in that case we say that this is either a case of extrema, which is actually maxima or minima. Next we check if double derivative at that point is greater than 0 or double derivative at that point is less than 0. So in this case we say that a is a point of minima, and in another case we say that a is a point of maxima. This was actually second derivative test. Actually I have introduced it in first derivative test, no problem. Second derivative, as you remember, this was second derivative test. How first derivative is different? In first derivative what we do, ki first derivative is 0, then we check that in its neighborhood first derivative like f dash a plus, which is again same thing as f of a plus h, is sine of this, and f dash of a minus. Now if this is a point of maxima, then we know that in case of maxima what happens, the curve goes like this, something like this. So the single derivative before a is actually positive, and single derivative after a is actually negative. So we say that this is the point of maxima. I hope this is clear to everyone. And if you talk about minima, then in that case what happens, that f dash of a plus is actually greater than 0 and f dash of a minus is actually less than 0. So here again in case of minima what happens, ki first slope is negative, a minus it is negative slope, and then a plus slope is positive. So we say that it changes like this. So you can check either by first derivative or second derivative if a function is differentiable, where it is maxima or minima. Other than this, these two methods, we have nth derivative test, where double derivative test fails and we don't want to apply single derivative test. So nth derivative test basically deals with the situation when double derivative test is not applicable. I hope it is clear to everyone ki what is double derivative test. In double derivative test, when you differentiate the function twice, it is either positive or negative, but we have not covered a case when it is equal to 0. So now the question comes ki when double derivative at a is equal to 0 and single derivative at a was already 0, that's why we are checking for extrema. Now if double derivative is again 0, then what happens, we cannot say ki it is positive or negative. If it had been positive, then it was a point of minima, and if it was negative, it was a point of maxima. But here it is 0. So what we do, we follow nth derivative test. In nth derivative test, we differentiate the function again and we calculate ki what is the value of triple derivative at a for that function. Now that value could be not 0 or 0. There could be two cases. What will happen if it is equal to 0, and what will happen if it is not equal to 0? Let's take when it is not equal to 0. Then in that case we have to comment that the point, the function at that point at a has an inflection point. Basically it is not a exact definition of inflection point, but for now we can understand this is inflection point. Otherwise it all depends upon concavity and convexity. Next, when it is equal to 0, then we further check that what is, then we say ki what is fourth derivative at a. Fourth derivative of a, when we check, then it could be positive, it could be negative. If it is positive, then we say that the point a gives minimum value of the function at a. I will just summarize this, and when it is negative, it gives a maximum value. Is this clear? Now again same question comes ki when it is equal to 0. Now this situation is same as this situation. double derivative and fourth derivative is same, because 4 is an even number, 2 is also an even number. Again same cycle goes on, and in a derivative test you can repeat this cycle any number of times till you get any of such situation where you can terminate. I can give you an example, like fx equal to x cube is a very favorite example of mathematicians when they give about inflection point. So when you differentiate it once, so you get it 3x square. When you equate it to 0, you get x equal to 0. Is this clear? Now when you put x equal, you double differentiate it, so it will become 6x. Now when you put 0, it will give you 0. So x equal to 0 was the point where we have to check for maxima or minima. Now when you put 0 here, this will become 6 into 0, that will be 0. Now double derivative is 0, that means double derivative test fails here. Now when we talk about any derivative test, what you do, you will differentiate it again, this function f triple dash x. What will happen? 6. Now which situation? It is not 0 or 0? It is not 0. That means this function has an inflection point at x equal to 0. That means at x equal to 0, if you see the graph of x cube, this graph is like this. And this x equal to 0 is neither maxima or nor minima, but is changing its nature, which is actually, it is convex upward and then concave upward. So this point is point of inflection. If you would have taken an example like this, fx equal to x to the power 4, this we are taking simple example. So what will happen? First derivative, it would come out to be 4x cube. You will equate it to 0. You will get x equal to 0. Then you will find this double derivative. You will see that this is 12x square. You will put 0. It will again become 0. Second derivative fails. You will take third derivative. This will become 24x. When you will put 0, it will become 0. This is not the case, but this is the case. So what will you do? You will differentiate it again, and that will get 24, which is not 0. And if it is not 0, we will deal like this. It is actually second derivative sort of thing, because it is again even. And in that case, if it is positive, this is the point of minima. Because in second derivative, we know if it comes out to be positive, it is a point of minima. If four derivatives coming to be positive, point of minima. So basically, this is the chain. This is a cycle which you have to follow in any derivative test. The statement has been written at various places that n is even and n is odd, and in the situation you have to check this thing. So I'm not writing those statements. I'm just giving you a cycle which you have to see, because this is actually you have to apply in the questions. And in this case, you will say, and if you see the graph of x to the power 4, this x to the power 4 is basically like this. X square has become x to the power 4, little more slopey. So in that case, you can say that x equal to 0 is the point of minima, which is a correct situation. Is this clear? Fine. Now we move on to, I'm just recapitulating everything that you have studied already. Global maxima and minima. And all these concepts we are going to use in different questions today. So you need to understand all these concepts, and that way you would be able to understand that how that has been applied in the those questions. So when we talk about fx function, and we say that what is global maximum point and what is global minimum point, or what is its global maximum value, whatever. So there are two things here again. If we are talking about an interval, so whether it is a closed interval or it is an open interval, broadly we divide it into two parts. It can be further divided, one open and one closed. So you can make a theory similarly if you understand the theory for this. So basically, when it is a closed interval, then we say that x belongs to a comma b. We check for all the points where its derivative is 0 or it is not defined. So if derivative of f dash x equal to 0 or not defined, which we call as critical points, we check all those points, let those points be x1, x2 till xn, and we also include the point a and b, which are the endpoints of the interval, and we check the value of the function at all of these points, that is n plus 2 points, and the value which is the maximum value is actually the global maximum, and value which is the minimum is the global minimum. If we talk about open interval, in that case we have to just check where f dash x equal to 0 or not defined. That means x equal to x1, x2 till xn. We don't talk about endpoint because they are already not included in the interval. But here again there is a point which you have to understand. Ki, if there is you have found out the function value at each of these points, n points, and you have found ki, suppose at some point it is maximum value and some other point it is minimum. But it may be possible that function may not have global maximum or global minimum at that point, though all of these points may was that value is the maximum value or minimum value. Reason being कि in this case the situation may arise where global maximum and minimum is not possible. Like you can take a function like this graphically. You take a point A, you take a point B, you take this value, which is actually A is not included at this value. You take a graph like this, like this. Now here this is a maxima, local maxima, and this is a local minima according to the definition, as well as derivative is 0, so these 2 points will come. Now when we talk about global maxima, is this a global maxima in this interval? No. But this is also not global maxima because this point is already not included. So there is not an exact value which can be said to be a global maxima. Similar cases with global minima, there is no exact value where it can be said to be a global minima. So there may be a situation here where local maxima and minima may be possible, but global may not be possible. Okay? But there won't be such situation here. I hope this is clear to everyone. So you can take it as a note. Ki, you can write it in a language. There is no guarantee, you can write it like this, of getting global maxima and minima in such situation. Now we talk about some important points regarding these things. Or we can move on to question, as we have already compiled all the important points which is actually needed. You can extend this to many other things as well as you go on, but basics revolve around these things. So when we talk about questions, so let us start with some few questions which would help us in building our concepts. First one is fx equal to x plus 2 whole square into x minus 4. Fine. Now you have to simply find your local maxima and local minima. When you differentiate this function, you will get x plus 2 ka whole square, and derivative of this is 1, and you will write x minus 4, and derivative of this is twice of x plus 2, rest is 1. You will take common x plus 2, this would become x plus 2 plus 2x minus 8, and this would become x plus 2, and this would become 3x minus 6, which would become 3 times of x square minus 4. Now what we do, we equate it to 0 as it is already defined at all other points, and we will find that x is either 2 or minus 2. So in that case we say this is the point of local minimum. Right now we cannot say, we can just say these two are the points of extremum points. Now we have to decide what is it is a minimum or maximum. So what we do, we again differentiate the above function. At double derivative here is not a very difficult process. In some questions it may be difficult to again differentiate it, it would become lengthy. So there we will take the help of first derivative. So if when we take double derivative here, this would become 6x. Is this okay? And when you put 2 here, so f double dash of 2 would be greater than 0, and f double dash of minus 2 would be less than 0. Greater than 0 means that 2 was actually a point of minima, and minus 2 means that it was a point of maxima. And when we talk about the value, minimum and maximum value, so what will be the value, minimum value? When you put 2 here, you will get 4 into f of 2 would become 4 square into minus 2, that would become minus 32. And when we put f of minus 2, that would become 0. Yeah. So minimum value is actually this. I hope this calculation part is okay. So when you calculate this minimum and maximum, you find out it like this. And when we take another question, find the maximum value of. So this was a basic question. This basic question actually gives you a direct application of the concept. That means how do you find local maxima and minima? Just differentiate it, equate it to 0, find the points, and then put those points in the function, and double derivative you take and you find out whether it is maxima or minima point, and then you will just find out the value of maximum value and minimum value. This is the standard process. But in many cases, there may be problems if you have applied these things just straightforward. Like even in case of differentiation, you have studied various types of differentiation. So when you have been given a question like this, that find the maximum value of fx equal to x ki power 1 by x. I think it is 1 by x ki power x. You can take anything, you can take that part as a homework. So this is 1 by x ki power x. Now you have to solve this. Here you will take the function 1 by x ki power x, but you cannot directly differentiate it, as you know it is a variable to the power variable. So in that case, what we do, we take log of fx and we write it like this, x into log of 1 by x. Then we differentiate this. This would give you 1 by f. Let us write it as f only to make it shorter. F dash equal to x upon 1 by x. Okay, into minus 1 by x square. I hope it is clear to everyone. Next, what we would do, 1 by f into f dash equal to, this would become minus 1. So you have this f dash x equal to minus fx. This part you have got here. Now when you want to equate it to 0, I think there have to be a product rule applicable here. I have just multiplied and just, so thank you have found it out. So basically this we have differentiated this, then we have to differentiate x and keep ln of 1 by x apart. So in that case now it's okay, and then you will write it like this, minus 1 plus ln of 1 by x, and when you write it like this in the next step, minus fx, this would be plus fx minus 1 plus ln of 1 by x. I hope now it is okay. There was a calculation mistake. So there was a product rule, as we know na, u into v ka jab derivative we do. So that is basically u dv by dx plus v du by dx. So that part, another part we left. So we have to do both the parts. Now what we have to do is we have to equate this derivative to 0, as we usually do in case of AOD in maxima minima. In that case, when we equate it to 0, what will happen? Either fx equal to 0 would be the case. We have actually equated f dash x to 0. So either fx is equal to 0 or ln of 1 by x minus 1 equal to 0. Now fx equal to 0 means 1 by x to the power x equal to 0, which is not possible, as an exponential function cannot be equal to 0. So this case we cannot take. We have to take ln of 1 by x equal to 1, which implies x equal to, this would become e ki power minus 1. You will take in the next step x ki power minus 1, and that would become e ki power minus 1. That is x would be basically 1 by e. So this is a point for consideration. Now this point can have a maximum or minimum value. Now you have to decide by double derivative. Now in this case we have to apply actually double derivative. Single derivative will actually land us into a bigger trouble, because this is a very complicated function and we have to decide, but you can do by single derivative as well. So let us differentiate this once again. When we differentiate it once again, what will happen? This function f dash, this would become f double dash, this would become f dash, and this would become minus 1, plus log of 1 by x plus minus 1 plus log of 1 by x. This part next we have to differentiate. So next we will differentiate this part, minus 1 will become 0, log of 1 by x will become 1 upon 1 by x into minus 1 by x square, and that f part will remain as it is. So next when we proceed here, now the point which we have to remember till here is that x equal to 1 by e. That is the only thing that we have to remember, and the function x ki power 1 by x ki power x. So function is x equal to 1 by e is the point, and function is x ki power 1 by x. I think this was the function we were dealing with. 1 by x ki power x, right? So this is actually 1 by x ki power x. This was the function, and we are dealing with this function. Now when you double differentiate it, this will happen. You find the value for single derivative at 1 by e, the point which we have got. Single derivative value at the point 1 upon e is actually f of 1 upon e into minus 1 plus log of e. This is what we will get from here, this part. Now log of e is 1, and 1 minus 1 will be 0. The single derivative at that particular point is 0, and that had to be 0 because we already got that point by equating it to 0, single derivative to 0. So that is single derivative is 0. Now this implies f double dash at 1 by e when we will calculate, this part will be 0. This multiplied with this, everything will vanish. Next we will write here minus 1 by x into f at the point 1 by e. This is what we have to do. When we put 1 by e here, this would become minus e, and f of 1 by e, and the function which we have is 1 by x ki power x. So when we put 1 by e there, this would become minus e into e to the power 1 by e. Actually this value has to be, I think when we differentiated it once again, we have differentiated this part 1 by x and minus 1 by x square, fine, into the function f as it is, and f of 1 by e, that would become I think it's okay. Calculation part we'll see. I think it is okay. F double dash of 1 by e is coming out to be e into e ki power 1 by e. So finally what I wanted to know is actually the sign, whether this sign is coming out to be negative or positive. So when we see the double derivative at this point 1 by e is coming out to be negative, which is actually a negative value, na? So we say that this x equal to 1 by e is a point of maxima. As I was saying that this could also have been done by single derivative method, and when we talk about single derivative, this was the function, and what you had to do in case of single derivative, that you had to put 1 by e minus value, and you had to just check what was its nature, negative or positive. That will give you the slope value. So when you put suppose a value less than 1 by e, 1 by e is roughly 2.712. So 1 by 2.712 से जो छोटी value होगी वो roughly 0.25, we can take it roughly like that, 0.25. So you take 0.25 here, 0.25 and 0.25 here, and when you will take 0.25 here, that won't affect the sign because it is f of x and it is 1 by x ki power x, which is actually exponential, which it cannot be negative in any case. So where it is, there is its domain, and this is positive. When you take 0.25 here, this would become actually 4. Log of 4 is actually greater than log of e. So log of e is 1, so log of 4 is actually greater than 1. So this whole value will be positive. We have got this value as positive, single derivative as positive at a value which is smaller than smaller than 1 by e. So basically at that point the slope is positive, that is the graph is actually increasing. Now when you take a point which is greater than 1 by e, so that point is quite easy to take. You can take 1 and you put 1 here, this would automatically be positive, and this when you put 1 here, this will log 1 0, this value will minus 1 will remain. Minus 1 is a negative value. That means after crossing that point 1 by e, the slope has become negative, which means ki, this is basically a point of maxima. This cannot be a point of minima. So it was already decided it is a point of extrema. Another thing which we decided it is a point of maxima. So we have solved the question. So by either method you can solve this question, either by double derivative or single derivative. We are talking about next question. Next question can be written as fx equal to x square minus 1 by x square plus 1. X belongs to real number and you have to find its minimum value. So basically again we have two methods here. One is the common algebraic method, that is we have to rearrange this and reduce it to only one variable. So when we write it like this, fx equal to x square minus 1 by x square plus 1 equal to x square plus 1 minus 2 by x square plus 1. After splitting the LCM, we get 1 minus 2 upon x square plus 1. Now when this value will be minimum, when this negative part would be maximum, negative part would be maximum, that will give you its minimum value. And when this negative part would be maximum, this part, when this denominator part would be minimum, because both are positive terms. And when this part would be minimum, when x equal to 0. X square plus 1 is minimum at x equal to 0. Negative it cannot be x square. So basically x equal to 0 is the point of minima for this function, and at f equal to 0 you will get the value minus 1, that is its minimum value. Now you have to do it again by let's say first derivative. So we take it or second derivative as the case arises. So when we differentiate it, what will become x square plus 1 ka whole square into x square plus 1 into 2x minus x square minus 1 into 2x. This is our quotient rule we have applied on of derivatives. This would become 2x, you could take common, and this would become 2, that would become actually 4x upon x square plus 1 whole square. Now this single derivative when equated to 0 gives you x equal to 0. So again we have got the same point for consideration. Now when you equate it to 0, what will happen? You have to again double differentiate it to decide whether it is maxima or minima. But this function is quite difficult to double differentiate. It is very easy to see that x square plus 1 whole square is always positive. There is no problem with that. We don't have to consider it even for sign. You have to just consider x, not even 4. When x, you take a value less than x equal to 0, that is a negative value. Actually x would be negative and this whole thing would be negative. And when you take a positive value which is greater than x equal to 0, then in that case this whole thing would also be positive. So actually this derivative is changing sign from negative to positive, and that we know from negative to positive the graph would be something like this, that is this x equal to 0 is the point of minimum value, and the minimum value is minus 1. This would another application where we can verify from different methods how a question can be solved. Now we can have next question which is little different from all these cases. We have found maxima, minima in these three questions anyhow. And now next when we talk about next one, this is fx equal to x minus 2 cube into x minus 3. Right. Now when we again find maximum and minimum points, okay, and even if there would be a point of inflection, then you have to find out that one also. So you differentiate it once, you find it x minus 2 whole cube plus 3x minus 2 whole square into x minus 3. This would give you x minus 2 whole square, and this would give you x minus 2 plus 3x minus 9 x minus 2 whole cube, it's fine. This would be 3x minus 2 whole square into x minus 3, and then you have taken x minus 2 whole square as common. So this would be x minus 2 into 3x minus, this would become actually 3x minus, it's okay. So this would become x minus 2 whole square, and this would become 4x minus 11. Now when you again equate this function derivative to 0, you get points. What are those points? Those points are 2 and then 2 and then 11 by 4. Actually they are 2 is double root. 2 is coming twice. When you have squared it, that is actually in quadratic, as we know that there could be a repeated roots as well. So this is sort of repeated root. Now when we talk about its double derivative, we take again differentiate 1x minus 2 whole square and differentiate this. This would become 4 plus 4x minus 11, and differentiate this 2 into x minus 2. This would become 2 into x minus 2, 2x minus 4 plus 4x minus 11. So which would become 2 into x minus 2 into 6x minus 15. Now this value is the double derivative. When we see 11 by 4, let's take 11 by 4. So when we take x equal to 11 by 4 here, what would happen? F double dash of 11 by 4 would become, you have to just see the sign. So 11 by 4 minus 2 is a positive value, and when you put 11 by 4 here, then what would happen? 11 into 3, 33 by 2, this would become again greater than 15. So what you will see that this whole thing is actually positive. This is what we see here, that this value is actually positive, right? So basically this is x equal to 11 by 4 is a point of minima for that function. Now when we talk about another point, that is 2. So when we talk about x equal to 2, then what will happen? X equal to 2 double derivative is actually equal to 0. So when we see that its double derivative is equal to 0, then it is again a derivative case, because you had to decide by double derivative. So you will differentiate it once again, 2x minus 2 into 6 plus 6x minus 15 into 2, or x, that part is 1, and then what you will do, this would become 12x plus 12x, that would become 24x, and this would become 24 minus 30, that would become, this would be 24 and then 30, that is 54, right? So you see that this value is 24x minus 54, triple derivative. When you put f triple dash 2 or calculate f triple dash 2, you will get 72 minus 54, that would become 18. 48 minus 54, sorry, that would be minus 6. Now here when you see, it is odd part is equal to minus 6, which is actually non-zero value. In case of odd, when we step in some odd part and we say that it is not equal to 0. So basically it is similar to, you have to, don't think about odd even, you just see it is triple derivative, that means it is same as single derivative. And if single derivative is not 0 at any point, then you don't say anything, it is not a minima or maxima, because single derivative has to be 0 or a defined sort of thing. So you can match it from there. So here we say that this x equal to 2 is neither a maxima or non-minima, and we can say it is a point of inflection. Is this clear? So here we come across another case where this repeated value is actually a point of inflection, and you can actually match this thing. And the example when we were studying about the concept, we took a cubic function there, that is x cube, and here it is also x minus 2 whole cube. So there is some correlation. You cannot make a theory like this, but you can understand, because that was a cubic function of a variable, here it is a cubic function. So this value actually where it is becoming equal to 0, which is 2, and there it was becoming at x equal to 0 as 0. So these two are acting as a same sort of things. Now there are many questions which deal with application of derivatives directly on geometry. Geometry as such, when I am talking about geometry, I mean to say that curves and spheres and like you have cylinders and cones, all those things, you have to minimize or maximize those areas and volumes under some condition. So in that case, how do you apply this concept? When we will come across those type of questions. So there is a question in which there is a box which is open from the top. That box is open from the top, and it is having a surface area given like this. This open part is open, but below there is a base. And basically in question it is given that area of the base is equal to 400 meter square, and you have to find that you have to find the ratio of edge length with the height under the condition. There is a condition given in the question where the volume is maximum. Fine. Achha, this is the area of this part which is not including the topmost cover, only the base and the 4 walls. And further it is given in the question that this is actually a square. So this would be if this base is actually x, then you can take this as well as x. So this is a sort of a square, and this area is 400 meters square. This is what they are saying in the question. Okay, and this height is actually y, which we have supposed. Well, this edge of the base we have taken as x, and the height of the wall we have taken as y, and we have been given that area which all of these parts make, surface area, is 400 meters square, and you have to find the ratio of edge length, which means x, with the height, that means y. This is what they are asking. You can imply this question like this, and it is given that its volume is maximum. So when we talk about the given condition, in such questions we have basically some fixed steps. First step is that what is given in the question, you have to write it mathematically by taking as least variable as possible. So we have already taken as least variable as possible, because you have taken already 2 same sides as x and height as y. So you cannot take same condition with height as well. So that is a different part. Next step is basically when you express this given condition in terms of different variables, minimum variables, you have to find out what you have to maximize or minimize. Here you have to maximize the volume of this container. So when you have to maximize the volume of this container, there may be possibility that it may have more than one variable when you write the volume of this container. So in such cases where there are more than one variable, you will use the condition which is already given in the question, and you have mathematically written it for expressing one variable in terms of another, and then you put that variable in this volume part, and then you have to differentiate it simply. So when we write about the area, this area is x square, which is actually base area, plus wall is actually x into y, the area of the wall, and there are 4 walls, so there would be 4xy, and this area value is 400. So here we have actually expressed 2 variables. Now when we talk about volume, let's take v, and that would become volume of this container is actually x square, which is the base area, into height, which is y. So we will multiply here. When we try to differentiate this volume, we come across 2 different variables. So it is quite difficult. So what we do, by the given condition, we express any one variable in terms of other. So I think we all realize here we can express y in terms of x more easily. So 400 minus x square upon 4x. This is how you get y. Now put that y here, and you will get V equal to x square into 400 minus x square upon 4x. Now you have expressed this whole volume in terms of x only. So this would become x by, you can do like this as well, x you divide, and you divide by 4 also, 100 minus x square upon 4. You can express this like this. Fine. This is 100x minus x cube by 4. It's okay. Now when you equate this, when you differentiate this volume dv by dx, you find it out 100 minus x square upon 4, and derivative of x is 1, plus x into 100 derivative is 0, minus 2x upon 4 is actually minus x upon 2. So this would become 100 minus x square by 4 minus x square by 2, that is minus 3x square upon 4, and you equate it to 0. What will happen? X square would come out to be 400 upon 3. This would mean x equal to 20 by root 3. Obviously we are going to take positive value. Edge length could not be negative, so there is only one value, 20 by root 3. And actually the easy part of such questions, geometry questions, is that you generally get such value for which you don't have to recheck for maxima or minima, because question already asks that when the volume is maximum and you have got only one value. So it is quite obvious in such cases that this will give you the maximum volume. This won't give you the minimum volume, because if you decide what should be x when the volume is minimum, so x should be 0, then you will get the minimum value, that would be 0. So we don't have to double differentiate it and then think whether it give you maximum minimum. You can just write that this value of x gives you the maximum volume. So x equal to 20 by root 3, then you will find y. So y would come out to be 400 minus x square, that would give you 400 minus 400 by 3, that is 800 by 3 upon 4 into x, that would be 80 by root 3, that would come out to be 10 by root 3, and this is actually y, and x we have already 20 by root 3. So the ratio which we have to find out is x by y is actually 2:1. This is your answer. So this is another application. Next, question which we will deal with is a cone inside a sphere. So this is another case where in geometry we have two figures. In previous question we saw only one figure, that was a box. In this question it is given that there is a sphere, and in that sphere there is a cone inscribed in it, and in here you have to find actually maximum value of cone, which can be inscribed or which can be inserted, sort of thing, inscribed or inserted, inscribed inside the sphere of given radius r. So it is already given that the radius is given part, and you have to find in that particular radius sphere what should be the maximum volume of cone which you can inscribe. So basically here again we have to decide some variables, and minimum number of variables you have to decide. So first of all, when we talk about the cone, there is a radius of the base of the cone and there is height of the cone. These two things you have to take anyhow. So when we take base radius, let's take it as x of the cone, and the height of the cone we can take it as, let's take it as y, and there is somewhere on this height center of the sphere. This part basically is from symmetry, that center would be somewhere here, and we can take it as O, and this part is actually radius r, and this part would become y minus r, the distance between center of the sphere and the center of the base of the cone, and this part is again, you have r. I hope this geometrical explanation is okay with everyone. Now using this geometry, you can find relation between two unknown variables x and y, because obviously when we talk about derivative, then we can differentiate right now with only one variable, but here are two variables, base of the cone as well as height of the cone. So based on Pythagoras theorem, what we can do, we can say this hypotenuse, that is r square, is equal to base square x square plus height square y minus r whole square. Now we can write it like this, r square minus x square equal to y minus r square, and then you can express either x in terms of y or y in terms of x, any way you like. So it is already x square, we can write it like this, that would be a better expression. Instead of y in terms of x, we can write we can do like this, we can write we can write y in terms of x instead of x in terms of y. Why? Because when we write it like this, x square equal to r square minus y minus r whole square, then we know we can apply the formula a square minus b square here, and when we apply the formula a square minus b square here, this would become r minus y plus r and r plus y minus r. This would get cancelled, and you can write it like this, y into 2r minus y. Now x square is like this, we may use this relation later on. Now let us come to the question. The question was actually volume is equal to, volume of the cone was 1 by 3 pi x square y. I hope we all know this formula, 1 by 3 pi r square h, and r is actually x square, h is actually y for the cone, and x square we already got as y into 2r minus y. So what we can do, we can write it like this, 1 by 3 pi y, and then this would become 2r minus y, and this would become again y. This would become 1 by 3 pi y square 2r minus y. So this is how we have done our two steps. Firstly, we have find a relation between x and y, and then in the volume definition of volume, we have expressed it in only one term. Now our next step is to differentiate that v with terms with respect to y, which is a variable. So when we differentiate this in terms of y, dv by dy, this pi by 3 is a constant, this don't have to do anything. This would become y square, and this would become minus 1 plus 2r minus y into 2y. This is what you will get, and then next you will write it as pi by 3, and this would become 2ry, that would become actually 4ry minus 2y square and minus y square, that would become minus 3y square, and when we equate it to 0, you will get y as either 0 or y as 4r upon 3. These are the two cases we are getting here. Now y equal to 0 we cannot take, because in that case the cone won't exist. So that is a case obviously of minimum volume, na? You have taken the height of the cone as 0. So obviously the other part 4r by 3 may give you, or will definitely give you, the maximum volume of the cone. So you can find the maximum volume of the cone as, you can put it in the formula 1 by 3 pi x square y, and that would become 1 by 3 pi, and x square as we expressed there was y into 2r minus y. There was a formula, na? This was the formula, I think. So you can put this value of y 4r by 3 in that formula we just wrote just before this, okay, and then you will get the volume, maximum volume. I hope it is clear to everyone. Now we come to another question. Actually the point here to understand is that there are some fixed steps that you have to follow, and there may be deviations in one or two steps. So you have to practice more and more questions to understand those changes. Next one is, you have a function fx equal to gx into x minus a square, where ga is not equal to 0. This is a pure mathematical sort of question, and here they are asking, find out when fx maximum or minimum, or at what value. You have to work out for fx when where it is maximum or where it is minimum, under what condition of gx it is maximum or minimum. It depends obviously on gx, fx depends on gx. So what would be the changes on gx that would make fx maximum or minimum, and what would be the point where this would happen. So when we talk about this function, again we differentiate it. So first when we differentiate it, f dash x, this will become g dash x into x minus a square plus gx into twice x minus a, and then we double differentiate it, or first we let us equate it to 0. When we equate it to 0, we get gx minus a as a common point, and this would become x minus a g dash x plus twice of gx equal to 0. So here there are again two conditions where the derivative would be 0. One is x equal to a, and another is this condition. Now let us see for x equal to a. So when x equal to a, what would happen? We differentiate it again. At x equal to a, derivative of f is definitely 0. Now we are working here for x equal to a, that whether it is a maximum or minimum, or why it is where it is maximum or minimum, under what condition. So we differentiate it again, f double dash of x. So this would give you g double dash of x into x minus a whole square plus twice of x minus a into g dash x plus twice of g dash x into x minus a, and then plus twice of gx. Again we have applied product rule here as well as here. Now when we put x equal to a here, f double dash of a would be equal to, here it would be 0 0 0, only you will get twice of ga. I hope you understand this part now. This is twice of ga. Now this twice of ga and this f double dash a is related like this. Now when we say that where fx is maximum or minimum, so we want to say that double derivative is negative or positive. This would be the case. Yeah. So double derivative is negative under what situation? When ga is negative. So f double dash is negative means ga is negative, and f double dash a is positive means ga is positive. So we can summarize the result like this. Result you can write like this, कि x equal to a is a point of maxima for fx if ga is negative, and we say point of minima for fx if ga is positive. So I hope this mathematical part is also clear to everyone, that how two different functions where we don't know this function as well as we don't know this function, and in that case we have to find out the dependency of one function on the other function for maxima and minima. So this is how we can solve in such cases. Next, you can also do for this but this is actually then become a part of differential equation when we will deal later on. Like this would become 1 g dash by gx, and you'll find the function gx. Okay. Now next question, again little bit of trigonometry we can involve in maxima minima as well, and we can understand how we can apply there. So there is a question, let fx equal to sin cube x plus lambda sin square x. And it is given that we are considering the interval pi by 2 to minus pi by 2. Find the interval in which lambda should lie in order. Find the interval in which lambda should lie in order that fx has exactly one minimum and one maximum. Fx has exactly one minimum and one maximum. Obviously, they are talking about local minima and maxima. So let us deal because it is an open interval. So when we differentiate this function, we get 3 sin square x into cos x plus lambda 2 times of sin x into cos x, and we equate it to 0. Now this trigonometry part we solve like this. We take common sin x, and then we can write even cos x could be taken as common, and the part which will remain is 3 sin x and plus 2 lambda. So okay. Now sin x could be 0, or sin x could be minus 2 lambda upon 3, or cos x could be 0. These are the three cases. Now in this case, between minus pi by 2 to pi by 2, x can give only one value, that is x equal to 0. What this would give is basically a question, because lambda when we know, then only we can decide about sin x. Cos x equal to 0 basically gives x equal to no value, because pi by 2 and minus pi by 2 is not included. So this would give none of the values. Now let us see one value we have got x equal to 0. Another value we may get from here, or more than one value we may get. Let us see double derivative of this function, or we can take single derivative as well. We have to just see the sign scheme. So let us talk about x equal to 0 first. When we talk about this single derivative part, this is your single derivative part, this is the function. And when we are talking about sign scheme before x equal to 0, so before x equal to 0, sin x is actually negative, that is a fourth quadrant, and this part is negative. Let us talk about cos x. Cos x before x equal to 0 is it is actually positive before x equal to 0, so this part is actually positive. And when we talk about 3 sin x plus 2 lambda, so we are not sure ki what would happen to this, because we don't know lambda. So this point is sort of fill in the blanks, we have to fill it later on. Now sin x equal to minus 2 lambda by 3. Sin x equal to minus 2 lambda by 3 would mean this part would become minus 2 lambda by 3. Again we don't know what is lambda, negative or positive, and here this would become double derivative, a single derivative we are talking about now. So just left of minus 2 lambda by 3, this would become almost minus 2 lambda by 3. Just left of minus 2 lambda by 3, this whole thing would become actually this sin x you are taking just less than minus 2 lambda by 3. So just less than minus 2 lambda by 3 would mean this whole thing would be positive. So this would be positive. And when you take sin x as minus 2 lambda by 3, you don't have to worry about cos x, because cos x has to be positive in any case, because the interval is already minus pi by 2 to pi by 2. So you don't have to worry about cos x, this would be positive. Now you have to find one maximum and one minimum value. When we see here that, let us take lambda some negative value. So what is happening here, this positive and negative is giving you negative, and this is here positive, positive is giving you positive. So now what you have to decide is lambda is playing a role here as well, and lambda is playing a role here as well. Here what is happening, that at x equal to 0, this value is 2 lambda. I hope this is okay with everyone now. At x equal to 0, this is 2 lambda. Now it is quite clear here ki, if you take lambda as some positive value, so this whole thing would become negative value, and this whole thing will become positive value. So that the role will interchange. One will automatically become maxima and another will be minima. If you take one as negative positive, let us take minus 2 lambda by 3 is positive, reverse case le lo. So in that case again one another will be maxima and first one will be the minima. So I hope it is clear to everyone ki whether you take lambda as any value, it would be true. Now they are saying ki in which interval lambda should lie. But one thing we have to keep this in mind, that sign value is not greater than 1 or minus 1. It has to lie between 1 and minus 1. Plus it is given that x is between minus pi by 2 to pi by 2. That means ki it is again minus 1 to 1. For sign it is okay. So you have to put only one condition, and that condition is that minus 2 lambda upon 3 is lying between 1 and minus 1. Is this clear to everyone? So this would become lambda actually lies between 3 minus 2 lambda and minus 3, and this you can calculate as 3 by 2, so reverse sign lambda, reverse sign minus 3 by 2. In such case you may get one maximum and one minimum value. Next question, let us see.
Sorry, last part repeat कर देना.
ये वाला पार्ट, ओके ये वाला पार्ट. इस वाले पार्ट में हम लोग ये कर रहे हैं कि लैम्डा की वैल्यू डिसाइड कर रहे हैं, जिस वैल्यू पे बेसिकली ये लाई कर रहा है, द इंटरवल इन विच लैम्डा शुड लाई, so that this function has one maximum and one minimum. एक मैक्सिमम और एक मिनिमम होना चाहिए. तो एक मैक्सिमम और एक मिनिमम होने का मतलब ये कि डबल डेरिवेटिव किसी एक का निगेटिव होगा, किसी एक का पॉजिटिव होगा. तो दोनों में से कोई एक निगेटिव पॉजिटिव हो सकता है. नाउ व्हेन वी डिफरेंशिएट इट वंस यू गेट दिस इक्वल टू 0. वहां से तुम्हें वैल्यूज मिल गई, यहां तक क्लियर है. फिर तुमने इसको फिर से डबल डेरिवेटिव नहीं लेके यू कैन डू लाइक दैट ऑल्सो. मतलब अगर ये वाला पार्ट थोड़ा सा तुम्हें सिंगल डेरिवेटिव वाला निगेटिव पॉजिटिव स्लोप वाला कंफ्यूज कर रहा है, तो यू कैन डू इवन लाइक दैट ऑल्सो, कि तुम यहाँ पे डबल डेरिवेटिव भी ले सकती हो. तो डबल डेरिवेटिव से भी इसको जब अप्रोच कर रहे होंगे तो यू विल गेट द सेम आंसर. और वी कैन वेरीफाई ऑल्सो, मतलब इन दैट केस इफ यू हैव टाइम फॉर प्रैक्टिसिंग यू कैन वेरीफाई बाय बोथ द मेथड्स. तो लेट अस वेरीफाई. सो दिस वुड बिकम sin x, 3 sin x plus 2 lambda, and this would become minus sin x again. Well, that would be a quite lengthy, so let us do one thing. First we write this f dash x in a shorter form. Shorter form I mean that you can write it like this, कि this is sin x into cos x is sin 2x. There is a formula in trigonometry after dividing by and multiplying by 2, and let us write it as sin x, and this part you can write it like 2 lambda sin x into cos x. Then let us differentiate this once again. So this would become 3 by 2 sin 2x, and this would become minus plus cos x plus 3 by 2. This would become cos 2x into twice, and this would become sin x. So you have got this thing, plus 2 lambda sin x minus sin x and plus 2 lambda cos square x, and equate it to, and now you have to find at its x equal to 0. So when you put x equal to 0, what will happen? F double dash of 0, this would be 0, this would be 0, this would be 0, this would become 2 lambda. F double dash x would become 2 lambda. I hope this is okay. Now when you put another value, where we are getting sin x equal to minus 2 lambda by 3. So where sin x equal to minus 2 lambda by 3, what would happen? F double dash of x, just calculate. Minus 2 lambda by 3, just put it where you can put, like sin 2x is actually 2 sin x into cos x. So this would become 3 sin x into cos square x. Sin x is minus 2 lambda by 3 and cos x is root over 1 minus sin square x. Sin square x is actually 4 lambda square by 9. Positive we are taking again for the same reason, pi by 2 to minus pi by 2, plus 3 sin x would become minus 2 lambda by 3 and cos 2x would become 1 minus 2 sin square x. 1 minus 2 sin square x means 4 lambda square by 9. I hope you are following this part ना. And फिर next कर लो, minus 2 lambda and this sin square x would become 4 lambda square upon 9 and plus 2 lambda into cos square x would become 1 minus sin square x, which is actually 4 lambda square by 9. Now just calculate this, what you get finally. This would become 3 and 3 and this would become minus 2 lambda by 3 root over 9 minus, this had become actually 2 sin x into cos square x. So this square root we don't need, it is okay, we can write without a square root. So this would become minus 3 cancel, minus 2 lambda and this would become plus 8 lambda cube, and then what you will do next is 8 lambda cube by 9 obviously, minus 3 to 2 lambda and then you can write minus 8 lambda cube by 9 again. So ये cancel हो गया और फिर हम ये लिख सकते हैं कि plus 2 lambda, तो this calculation is becoming easier, minus 8 lambda cube by 9. So finally what we get is minus 2 lambda common and this would become 1 plus 4 upon 9 lambda square, right? So here what we observe, we are getting this value. Now when you see this value and this value, what is the difference? If you take any value of lambda, this would become positive and this would become negative for positive value of lambda, and for negative value of lambda this would become actually negative and this would become positive. There is another case also which we actually missed in the previous way, and we said when lambda is positive and when lambda is negative. One case which arises now is when lambda is 0. We haven't discussed that case. So actually we said previously also that when lambda is positive, one is positive, and when lambda another is negative, and when lambda is negative, one is negative, another is positive. Here actually exactly same case arises, that when lambda is positive, this is positive and this is negative, and otherwise it is just opposite. What if lambda is 0? So in that case this would be also 0 and this would also be 0. Then that would be a case of triple derivative. Is this clear? So instead of doing triple derivative and everything, for lambda equal to 0, you just see the function. What is the function actually is? Function which we took was sin cube x plus lambda sin square x. Sin cube x plus lambda sin square x. So when you want to know for a single value, why to do all the calculations? Cross check for lambda equal to 0. Maybe lambda equal to 0 may not come in this interval. We directly wrote ना कि लैम्डा नेगेटिव पॉजिटिव कुछ भी ले सकता है, लेकिन लैम्डा के ऊपर एक कंडीशन है, मतलब माइनस 2 लैम्डा बाई 3 पे एक कंडीशन है जो एफ डैश एक्स इक्वल टू 0 से आया है कि वो 1 और -1 के बीच में होता है, लेकिन इट मे बी पॉसिबल कि 1 और -1 के बीच में एक 0 वाला केस हम ना भी ले सके. सो यू हैव करेक्टली मतलब राइटली pointed it on time to revise this whole part, because there is a case that lambda equal to 0 we could have included, but here lambda equal to 0 is a case which is neither positive nor negative. I hope everyone understood this part. Now we took one thing positive, another is negative, but we forgot about 0 part. So when lambda equal to 0, this fx equal to become sine cube x. Now in that case, when we talk about fx equal to sine cube x, So here which type of function is this? Matlab, is this at x equal to 0 minimum or maximum or something like that, and x sin x equal to minus 2 lambda by 3? This is also actually correct, because you will get only one point. If you take lambda equal to 0, you will get sin x is equal to 0. जो दो केसेस हमें मिल रहे थे, एक मिल रहा था x इक्वल टू 0, एक मिल रहा था sin x इक्वल टू -2 लैम्डा बाई 3. अब वो दो केसेस नहीं मिलके एक ही केस मिल रहा है, क्योंकि ये sin x इक्वल टू 0 बन जा रहा है, और ये भी हमें वही दे रहा है जो पहला वाला दे रहा था, दैट इज x इक्वल टू 0. तो जब हमें एक ही वैल्यू मिल रही है, तो उसी एक वैल्यू पे मैक्सिमम भी मिल जाए और मिनिमम भी मिल जाए, तो ये तो पॉसिबल ही नहीं है. तो एक मैक्सिमा और एक मिनिमा, दो केस जो हमारे क्वेश्चन में था कि एक मैक्सिमा भी मिलेगा और एक मिनिमा भी मिलेगा, वो पॉसिबल नहीं है. So we say कि lambda equal to 0 we cannot include. I hope it is clear to everyone. Na? We don't have to go for plotting the function. It is clear from here. Then when sin x equal to 0, then x will be 0, and that is the same case as the another one. अब clear है? तो ये डबल डेरिवेटिव से भी एक्सप्लेन कर सकते हैं, वहां सिंगल डेरिवेटिव से भी वही लॉजिक लग रहा था. ठीक है, उससे भी वही हम लगा रहे थे कि ये पॉइंट भी अगर एक्सप्लेन करोगे तो ऐसे ही करोगी कि -π/2 से लेकर π/2 में जब sin x है, x है, तो sin x की वैल्यू -1 से 1 के बीच में होती है, उससे हम लैम्डा के इंटरवल निकाल रहे हैं, और बस एक वैल्यू हम एलिमिनेट कर रहे हैं, दैट इज लैम्डा इक्वल टू 0. लेट अस कम टू अनदर क्वेश्चन. In coordinate geometry, basically we have used this application of derivative in everything, in geometry, in trigonometry, in normal algebra, and obviously in calculus. Now we will use this concept in coordinate geometry as well, and particularly in parabola. So in this you have to write this, in the final answer, keep this in mind that you have to write this thing कि here lambda is -3/2 से 3/2 except 0, or you can write it like this: lambda is greater than -3/2, less than 0, or lambda is greater than 0 and lambda is greater than 0. Anyways, you can write this. Find the shortest distance of the point 0, C. Find the shortest distance of the point 0, C from the parabola y equal to x square where C lies between half and 5, where C lies between half and 5, and 5 is included but half is not included. Firstly, this is a parabola y equal to x square, which is actually upward opening. We all know in coordinate geometry. Now there is find the shortest distance of the point 0, C. 0, C is a point on the y-axis, somewhere here. So what is the best way to find the distance of this point from a point on the parabola is to let us take the point on the parabola in parametric form. So when we take x equal to, let's say, t, then we take y as t square. So actually we are doing the same, applying the same concept which we applied in geometry part, that instead of using many variables, we are minimizing the variables. So here only one variable we have used, that is t. Next, when we talk about the distance, so distance is root over t square plus t square minus c whole square. That is the distance between these 2 points. And in case of maxima or minima, you don't worry about a square root. You can just take that as distance. If distance, you have to find minimum, that is its square is also minimum at that point. Distance is a positive quantity, so distance square you can take as minimum. वैसे if you want to take root, then also you can calculate, but that will make the question lengthy, solution lengthy. So what you will do, you will just take a square of the distance and then differentiate this square of the distance. So when you differentiate this, actually I have taken d, let us take it as some variable as f, because d we use for differentiation. So d of f square we have to do with respect to t. T is the variable, that is d of t square plus t square minus c whole square upon t. This would become 2t plus 2t square minus c into again 2t. So this will become 4t, and then we will write it like this. 2t, and this would t you can take as common as well. So this will become 4t square minus 4c plus 2. Okay. So when we equate it to 0, then in that case you will get one thing, that is t equal to 0 also you will get, and here you can take t equal to 0 one as a one case. As a one case you can take t equal to 0 because t equal to 0 is this point where x and y both will become 0. And you again take t is 4t square minus 4c plus 2 equal to 0. That would be a quadratic equation whose solution will be the solution of 2t square minus 2c plus 1 equal to 0. 2 we have taken common. So this would give you, this is minus 4c only, right. So this will become t equal to 2c minus 1 upon 2 with root and plus minus sign. Now this plus minus sign which is coming is quite logical, because t plus minus means ki x square is not going to be negative, but y could be, basically y cannot be negative, but x could be negative. X is actually t and y is t square. So t you can take positive as well as negative with the same numerical value, because if there is a value here, there is a symmetrical value here also. This is symmetric about y axis. So if some value here is giving you the shortest or longest distance, then the similar point will be giving you the shortest or longest distance here also, because these are symmetry. So it is logical that you are getting plus minus sign there. Now next step is to find these three values. Basically instead of three values you can narrow it to two values. For plus you can find it out, and for minus you can give the same result. Actually this right part will give you the same result for the left part. So now we either try the single derivative test or the first derivative test. So let us try the double derivative test. So we differentiate this f square with respect to t again, and what will happen? 4t square minus 4c plus 2, and t would become 1 plus, and this would become t, this would become 8t, and this part will become 0. Now this double derivative at t equal to 0 will give you 2 minus 4c. It's okay. This double derivative is giving you 2 minus 4c. Now it is in terms of c, but there is something about c. C is between half and 5. Then 2 minus 4c will be in which region? You can find. So let us multiply this c with 4. The 4c is between 20 and 2, which means minus 4c is between minus 2 and minus 20, which again means 2 minus 4c is between minus 18 and 0, which means under the given condition of c, you will always get this value double derivative as a negative value. This is actually less than 0 under that condition. This is clear. So this value is negative, and if this value is negative at this point t equal to 0, that means this is a point of maxima. That is a point of local maxima actually. So this point is a point of local maxima from this point. When we talk about t equal to root over 2c minus 1 by 2, what will happen? Double derivative, put it there. So double derivative would become t square का मतलब हो गया 2c minus 1 by 2, that is c minus half. C minus half minus 4c plus 2, and then plus 8t square again. So that would become 8 2c minus 1 by 2, that is c minus half. So this would become 8c minus 4c, that would become 4c plus c 5c, and then minus half plus 2 would become 3 by 2, and then minus 4, that would become minus 5 by 2. C and 8c 9c, it's okay. Minus half 3 by 2 minus 4 plus 3 by 2 would become minus 5 by 2, right. So this would become 5c minus 5 by 2, Now again same condition, let us evaluate. 5c minus 5 by 2, what will happen? You will first multiply by 5. So this would become 5 by 2, this would become c, 5c, this will become 25, and then subtract 5 by 2 everywhere. So this will become 0, this will become 5c minus 5 by 2, और ये कुछ भी value आएगी, that would be a positive value. 25 minus 5 by 2, let's write it like this. So 5c minus 5 by 2 is a positive value. So this is actually a positive value at this, which means that this is a point of local minima. That point is actually root over 2c minus 1 by 2 comma 2c minus 1 by 2. Y coordinate is actually without square root. I hope it's clear now. Similarly, you can say this point is also a point of local minima. So basically what is happening geometrically here is that when the distance we are talking about here, this graph is going to infinity. So when we are talking about distance, this distance is quite large, infinite distance from here. But when you are coming closer and closer, the distance is decreasing. And here there is the minimum distance. Then again the distance is increasing. And then again there is a maximum distance, which is actually we are saying local maxima, because it is not a global maxima. Global maxima is actually infinite. The distance between this point and the point on parabola is infinite. But that distance is decreasing, then again increasing, then again decreasing, and this is the minimum value, then again increasing. So when we talk about the distance, there would be a graph like this. It is coming from infinite, then it is coming to a minimum value, then it is slightly increasing, then again minimum value, then again it is increasing to infinity. I hope this is clear to everyone, the application part of this coordinate geometry, to coordinate geometry. So you can say that this point is actually minus root over 2c minus 1 by 2, this plus root over 2c minus 1 by 2, and this is 0, the only one point which is the local maxima. Now let's take again applied geometry. So I think we have covered almost all the application which is quite possible and the questions which come across. Now it is about practicing, that you would know that in different situation and in different cases how you can apply this concept. So let us write one more question. A window of fixed perimeter, there is a window which is having fixed perimeter, including the base of the arc, including base of the arc, is in the form of a rectangle surmounted by a semicircle. So this is a rectangle surmounted by a semicircle. You can write it more clearly, draw it more clearly like this, semicircle. And then it is given the semicircular portion is fitted with color glass, while the rectangular portion with the clear glass. There is a transparent glass here and there is a colored glass here. And result of that is that the clear glass transmits 3 times as much light per square meter as the colored glass does. So the light that is coming from the window, here it is coming out to be 3 times more than here. So if you say that the amount of light per square unit is coming from here is, let's say, A. You can write light in any terms. So per square unit light which is coming is A, and the light which is coming here is actually 3A, which is coming per square unit light. Now what is the ratio of the sides of the rectangle, this rectangle, the ratio of the sides of the rectangle, that is x is to y, so that the window transmits maximum light. Okay, so x is to y का ratio हमें पता करना है, so that window transmits maximum light. Overall हमें maximum light मिल रही हो. Now fixed perimeter is given. Perimeter is fixed. You can assume the perimeter is P. So in this case, this has been given including base of the arc. That means कि this part is also included in the perimeter part. So if this would have not been given, then obviously perimeter you would have taken like this. Now just do first step, that is you take the given quantity, that is P, in terms of the other variables. So other variable is the surface area. The light which is entering is actually dependent on surface area. So surface area is x into y, length into breadth, plus this semicircular part. This semicircular part is actually having the radius as x by 2, half of the width of the rectangle. And when you talk about the semicircular area, that is half pi x by 2 whole square, semicircle area. Now this would become xy plus pi x square by 8. This is the given case, and what you have to find it out is the maximum light. So light, amount of light would become, actually we have interchanged few things. This is actually amount of light, right? Because the area is actually amount of light. Right, left I have written that perimeter part, and right I have written that amount of light. So that is got confused. Amount of light is actually x into y, its area, into 3a, that is the amount of light that is coming. X into y is the square unit of the area, and 3a is the amount of light per square unit. So if you multiply the amount of light per square unit with the area, you will get the total light. And similarly here you have to multiply with a only, because यहाँ पे point is that कि 1/3 जो है that light is entering. So this would become 3 times of xy, and that would become like this. A is common, and a you can take like this as common. And next, what was the given part was P equal to perimeter is actually x into y plus, sorry what I am doing, x plus x, that is 2x, plus y 2y, plus the part of this circumference is pi into r, that is pi x by 2. I hope it is clear to everyone. Na? So this is 2 pi r is the perimeter, and we are taking as pi r only. This would become 2x plus 2y plus pi x by 2. Now again third step is that you express any one variable in terms of the other. Best way is that you express y in terms of x, that is p minus 2x minus pi x by 2 upon 2. This 2 would cancel, this would become 4. So we have expressed x in terms of y in terms of x. And next what we are doing is amount of light, which is actually a into 3x, and y comes out to be p by 2 minus x minus x minus pi x upon 4, right? And then we have plus pi x square upon 8. This is what we get here. And then we have, first let us simplify this, then we will differentiate a. So this would become a common 3px upon 2 minus 3x square, and then this would become minus 3 by 4 pi x square plus pi x square by 8. So minus 3 by 4 plus 1 by 8, that would become minus 5 by 8. So this would become minus 5 by 8 pi x square. And then in the next step we can write it like this: x as common, 3p by 2 minus x is common inside here, 3 times plus 5 pi by 8. This is what we will get here. Now let us differentiate. So when we will differentiate this a, what will we get? D of a by d of x. So first we differentiate this part, a and x would become 1, 3p by 2 minus x, 3 plus 5 pi by 8. Next what we can do is a into x, and inside one will become minus 3 plus 5 pi by 8. Right. When we equate this to 0, or before equating to 0, we can simplify this as well. A is actually common again, and here 3p by 2 minus 3 plus 5 pi by 8 into x minus 3x, and then minus 5 pi by 8 into x, right, and this would become equal to a 3p by 2 minus 3x and then minus 3x again minus 5. This is twice, na? So 2 times of 3 plus 5 pi by 8 into x. This is all calculation which we are doing. So this little bit calculation. If this question would have been given that its perimeter is, let's suppose, 800. So this would have been easy, as p we could have put in here and we could have calculated. So we are taking as p. Now let us differentiate. So differentiate we have done. We'll equate it to 0. dA by dx equal to 0. So this would go. This would become 0. Minus 2. This would become 0. Okay. Right. We have already differentiated now. So this would become 3p by 2 equal to 2 times of 3 plus 5 pi by 8 into x. So this would become x equal to 3p by 4 into 3 plus 5 pi by 8. And what we had to calculate was the ratio of x and y. And if we remember, y was actually, in terms of x, we wrote y as 3 minus x. This is what we wrote. So
P by 2 minus x minus pi x by 2.
minus pi x by 4. This is what we wrote. So y equal to, we can calculate as p by 2 minus, this calculation part is again tricky part is basically. So this is x 1 plus pi by 4, and then you put x value here, and then you'll find the ratio. So this calculation part, I hope you will do this ratio. So this answer I would tell you. You can cross check the answer later on. This answer is actually a lot of calculation here. 6 upon 6 plus pi. The final answer which you will get is 6 upon 6 plus pi. So you can calculate that part and you get this answer. We can do one more question here. Like, we have another question. That is again this type of question you have come across in differentiability. When you study differentiability, you had come across this question. Fx equal to 2x cube minus 3x square plus 1, and gx equal to actually maximum ft x square plus 3x plus 7, 0 less than equal to t is less than equal to x, and 0 less than equal to x less than equal to 2, and here 2 less than x less than equal to 3, and they are saying test continuity, which we used to do in case of this type of questions in continuity and differentiability. So but here we have to do check its continuity. So I would just give you an idea how to attempt this. I won't do this right now. This may be a task for the next class. As we used to do it in differentiability, we would find the nature of this gx graph, how it will move, its derivative we have to find it. Maximum of ft, you know that when t is between 0 to x and x is between 0 to 2. So how this function fx behaves. So you can complete this part as a homework, and then we'll discuss this if there would be any problem in the next class. So the basic type of questions which could have been come in any type of exam, from basic to high level exam, or which will come most probably in any exam, we have covered almost all types of problems and application of maxima and minima basically in all such problems. So if you practice these type of questions and if you revise this type of questions, then it would help you a lot. Okay, thank you class.